it. Okay. So Gargi, at the start of lecture daily you will remind me that I have to record the lecture. You will get this recording on your Namaste Physics app. Electrical. So electric field due to a thin spherical shell. Let us see how to find out electric field using which law? Using Gauss law. Okay. Now is it visible? Okay. Is it visible now to all of you? Okay. So let us proceed. Here is first of all outside. I told you there are two cases. One is inside, other is outside. First of all outside. Let us see. Here is a spherical shell, hollow spherical charge shell. It is having a charge on its outer surface. Charge never penetrates inside. So this is having a charge plus Q, and the radius of this spherical shell is capital R. There is a point P outside the surface. There is a point P outside the surface at a distance R from the center C, and you have to find out electric field on this point. So what I told you, first of all, this charge is there on the shell, so you will consider a Gaussian surface. Given the distance of point P, that is R, is greater than R. It means you are outside the sphere, and you will draw a, now consider a spherical Gaussian surface. Consider a spherical Gaussian surface like this. This is a spherical Gaussian surface. What is this? Gaussian surface. Now you will consider an area vector over here. This area is what? ds. Now you will make electric field from here, from here, this is electric field E. So this is electric field E. Now this point, this point, this point, this point, this point is at equal distance from the center. So all these points will have same electric field. It means this Gaussian surface is symmetric. Okay. Now apply Gauss law for the whole surface. Now apply Gauss law for the whole surface. Always we apply the law for the whole surface, because integration you are doing for closed surface. So I will apply E dot ds equals q net upon epsilon naught. First of all, open this dot, and what is the angle between E and ds? Theta equals to 0 degree. So may I write E ds cos 0 equals q net upon epsilon naught. Take out E from the integration sign. Integration ds equals how much charge is enclosed, that is the charge on the surface, q upon epsilon naught, and the integration of ds is the total surface area of this Gaussian surface. Total surface area is E into S equals to q upon epsilon naught. What is total surface area? 4 pi r square. So may I write E into 4 pi r square equals to q upon epsilon naught. So E equals to 1 upon 4 pi epsilon naught q by r square. It's all. This is the final formula. Do it. Write it on your copies. Whenever complete, write D. Okay, let's proceed. Let's proceed. Now we see inside. This was outside and now we see inside. Inside. For inside, now the point P lies inside the surface. So may I write R is less than R. means its distance is less than the radius of the surface. Suppose this is your spherical shell having charge plus q, right? And this is the center. This is the radius r of this particular sphere, and here is point P. This is point P, and on this point P, this is at a distance r. So I have written down r is lesser than r. So on this point P, you have to find out electric field. So consider a Gaussian surface, round Gaussian surface. Consider a spherical Gaussian surface from point P. Now I apply Gauss law. E dot ds equals q net upon epsilon naught. I am giving you a advice, and this advice is very very important. Whenever you consider Gaussian surface, you just take an idea what is the amount of charge inside it. Inside it there is no charge. All the charge lies outside the Gaussian surface. You can see this is outside. No charge is there inside the Gaussian surface. Inside the Gaussian surface, Q net is equal to 0. There is no charge inside it. It is empty. So may I write E dot ds equals 0. 0 upon epsilon naught. Put Q net equals to 0. So it implies if this value is 0, then E equals to 0. So electric field is 0 inside the charge hollow sphere. So electric field inside the charged hollow sphere is 0. Do it, write it. There is nothing complex inside it. Inside it, no charge is there. You can see inside the Gaussian surface there is no charge. Each charge, whole charge is existing outside the Gaussian surface. So inside it, charge is 0. So I can say over here, no charge, no electric field. Do it. Chali. Now have the next heading, the result and the analysis, graph between electric field and R. Graph between E and graph between electric field and distance from the center. What is R? R is distance of point from the center. And what is R? R is radius of hollow sphere. Let me share you the board and let me tell you what is the main secret things of this point of this system. Let me explain you. Look, dear students, there are, I told you two positions, but there are three positions, right? Actually, there are three positions, but I told you only two. First position is there inside. You start from here. Here r equals to 0, and this is the radius capital R. Now you are moving outside from it. Then on this point, on each point, electric field is 0. So R from 0 to R, what is electric field? Electric field is 0 because you are inside. Now you reaches on the surface, exactly on the surface. This is the main important point of consideration, exactly on the surface. Can you tell me what is the electric field? No. Nobody can tell the electric field on the surface, so it is not defined actually. The electric field due to a charge on itself is not defined. We cannot find it, and nobody can find it. It is actually, it is considered to be 0. Okay, so because if you can be, you will be able to find out this electric field, it will apply a force on itself. So on, if somebody is asking you what is the electric field on the charge by itself, you will say I don't know, it is not defined. So on the surface it is not defined, but on the next point from the surface, suppose this point is next point, and I can consider its distance to be r, that is not a problem, then it is outside. So the electric field over here is 1 upon 4 pi epsilon naught q by r square. Now I put r equals to r. The distance of this point from the center is equal to r. So on the surface, we generally write it that on the surface electric field is q by r square, and this is having maximum value. This is having maximum value, right? And as we move further from it, now electric field, you know, E is equal to 1 upon 4 pi epsilon naught q by r square. So electric field will go on decreasing. So it means if you see various positions from here to here, electric field is minimum. On this point next to the surface, this point next to the surface, electric field is maximum. And how much is its value? It is this. And after it, it will go on decreasing. So if you will draw a graph of it, the graph will be like this. This is the center. If I draw a graph like this is y-axis, this is x-axis, this is electric field, E, this is distance from center, R. Here is what? Here is the center, and on the center electric field is 0. Then you move away from center to the surface like this. Let me change the pen. Then from here you move center to the surface. So you are moving toward the surface, and this is the surface point. And this is surface point, means the next point to the surface, means you have reached on this point at a distance r from the surface, and you find at this point electric field becomes maximum. Here electric field becomes maximum, and its value is k q by r square. Here from this point to this point you are inside the globe and r is less than r. Now as you move further, r is greater than r and you are outside. And we generally write it on the surface. This is called as surface, but you know the secret. Actually, this is next point to the surface, and in this region, E is inversely proportional to R square. So electric field will go down like this. It will go down. Like this. So this will be the graph. From here, center to the surface. On surface, it becomes maximum, then it starts to decrease. Okay, so let me tell you, let us draw the graph on main page. So here I am going to draw the graph. This is your axis, this is x-axis, distance from center, that is equal to r, and this is what electric field, this is equal to E. From here you start, this is what, this is center. Here from here you move outside like this, right? So up to this point here, this is inside point, r is less than r, and on the next point to the surface exactly, the electric field becomes maximum, and on this point electric field is maximum, and it is k q by r square, and it is having maximum value. And on this point r is equal to r. From this point to this point r is less than r, you have written down over here. After that you are outside, and in this region electric field is inversely proportional to r square. So you can draw the graph like that. Right? This is a hyperbolic graph. E is inversely proportional to r square. So you can draw it like this. Come on, do it. Draw it, and whenever complete, write done. This graph, remember one thing, this graph will not touch this line. This graph will not touch this line, because this, if this graph touches this line, in this case electric field becomes zero and r becomes infinity. And infinity is that thing which is not possible. It is not possible, so you will never touch this graph to this line. You will show a gap always. In this region you can write down, here r is less than r, and here r is greater than r. So in this graph, from where electric field starts, electric field is starting from this point. Before it there is no electric field. Here electric field is zero. So this is not the line of electric field. Electric field is starting from this point. From the maximum value it is starting, and it is going on decreasing. This line is not the electric field line. It is starting from this point. Now let's move to the next discussion. Till now you have seen two cases in which the Gaussian surface was spherical. Now I will consider a case in which the Gaussian surface will be cylindrical, right? So I have told two types of Gaussian surface. One is spherical, other is cylindrical. But remember one thing, cylinder has three surfaces. Let me tell you. Next heading, come to the next point. Electric field due to infinitely long straight charge line charge distribution or wire. You can write wire also. So let me explain the things. Electric field due to a long, infinitely long, very long, infinitely long. Second is straight, uniformly charged, or you can write charged wire. Wire, you may write wire or line charge distribution, whatever you may want to write, or linear charge distribution. Whatever you want to write, you can. So electric field due to infinitely long, straight, uniformly charged wire or linear charge distribution. This is the case. Here, this is a line. This line is infinitely long. This side, it is up to plus infinity, and this side, it is up to minus infinity. This is positively charged, and yes, naturally, if it is infinitely long, the total charge on this wire is infinite, right? So there is a point P. Here is a point P. Here is a point P at a distance R from the line. Okay, you have to find out electric field on this point P, right? Now we shall proceed in the same way, and we shall consider a Gaussian surface from this point. Look at this point and consider a Gaussian surface. How, what type of Gaussian surface? Here you cannot consider spherical Gaussian surface because it is linear. So Gaussian surface should be lengthy also. So you will consider a cylindrical Gaussian surface. But the question arises, what is the length of this cylinder? The length of the wire of the wire is infinity, so there is no idea to consider the Gaussian surface as infinity. You cannot consider it as infinity, so you have to consider the length L of the Gaussian surface. Means the length of the cylinder is L. Suppose this is the Gaussian surface and I am considering it like this. This is Gaussian surface. The length of this cylinder is L. And how much charge is there inside the Gaussian surface? This Gaussian surface starts from this point, ends from this point. This length is L, and suppose this charge which is enclosed inside the Gaussian surface is Q. And you know one fact, linear charge density means charge per unit length is called as lambda. And what is the value of lambda? Lambda equals to Q by L or dq by dl. This is what linear charge density or charge per unit length. This is not a special thing. This is a simple physical word, charge divided by length. So total charge in the Gaussian surface is Q and total length of the Gaussian surface is L. So charge upon length is equal to Q by L. Now consider electric field due to it. Make electric field due to the wire. So I am going to make the electric field due to the wire. Electric field will be naturally, this is a body, it will be perpendicular to the wire and away from it. But before it, now listen to me carefully. What is this? This is cylinder. And look, this is a glass. Consider it as a cylinder, or this is a copy. Consider it as a cylinder. Now it has three surfaces. Three surfaces it is having. Let me go. It is having three surfaces. One, this round surface. You can see this round surface. This round surface. Other, this circular surface, and other, this circular surface. This one, this one, this one. So this whole cylinder is made up of three surfaces. 1, 2, and 3. If this radius is r, this is what? Pi r square. This is what? This is pi r square. What is the area of this surface? This is 2 pi r into L. The length of the cylinder is L. And this area is actually equal to this area because this is a uniform cylinder. This is a uniform cylinder, you can see. So this type of surface is there and the wire goes from inside like this. Okay, so this is a cylindrical surface. Now there are three areas. This surface is made up of three areas. So I will consider three area vectors. This is the most important point. So I consider an area vector over here. This is like this. This is ds1. An area vector over here on the second surface. This is ds2. and an area vector from the point. Obviously, it has to be considered. It is what? It is ds3. In sphere, there was only one area, but in this there are three types of area: one at this side, other at this side, and third is round, like this. So now I would like to make the electric field. I would like to make the electric field. Now this is a wire. What type of electric field it will produce? I will make like this, like this, like this, at one side, other side. It will produce electric field like this. This is what? This is electric field, right? From the wire. So it will go on producing like this. So, and on each side it will produce like this. So what is the next step? Apply Gauss law, for which you apply for the surface. For the Gaussian surface, this is Gaussian surface. And for the Gaussian surface, you apply Gauss law. Apply Gauss law for the cylindrical surface. And you write E dot ds equals q net upon epsilon naught. Now this surface is made up of three surfaces: ds1, ds2, ds3. This is 1, this is 2, this is 3, right? So let us break the whole cylinder in three parts. First surface is A, so I may write it E dot ds1. This cylinder is made up of three surfaces. First is this, second is this, plus E dot ds2 plus E dot ds3 equals how much charge is there inside the surface? Q. The charge is Q. Q upon epsilon naught. You consider the charge as Q. Now look at the angle. This is what? This is electric field. What is the angle over here? This angle is 90 degree. What is the angle over here? This angle is 90 degree. What is the angle over here? This angle theta is 0 degree. Right? This theta is 0 degree. So put the values, and I told you in most of the places you will find theta equals 0 degree or 90 degree or 180 degree. These are the three most popular values of theta in case of Gauss law. So you will find these values, so there will be no problem in applying this. So let me write E ds1 cos theta लिखोगे ना, you will write cos theta, and cos theta between E and ds is 90 degree, cos 90 plus E ds2, what is the angle? Cos 90 plus E ds3, what is cos theta? Cos 0 equals to what? Q upon epsilon. So let me explain it further. E ds1 cos 90, this is 0. E ds2 cos 90, this is 0. Plus E ds3 cos 0, this will become E ds3 equals q upon epsilon naught. And you know, this surface point, each point is on distance r from the wire, and charge is same, so electric field is same on each and every point of the Gaussian surface, so electric field is constant. This is the most important step to take out from it integration sign. So E integration of ds equals to q upon epsilon naught, and yes, this is ds3, and yes, what is this ds3? It is nothing, this is the round area, this curved area of the surface of the cylinder. So may I write E into, this integration will cancel out this d, es3 equals to q upon epsilon naught, and s3 is what? It is the curved area of cylinder, and if the cylinder is like this is the curved area, and if the radius of the one side is r, and length of the cylinder is l, then this curved area is 2 pi r. This is what? This is s3. Now put the value of s3, e into 2 pi r l equals q upon epsilon naught, e equals to 1 upon 2 pi epsilon naught r into q upon L. This is Q, this is L, and what is Q upon L? You know, this is lambda. So what is E? E equals to Q by L. Put Q by L equals to lambda, lambda upon 2 pi epsilon naught R. This is the formula of electric field at a point P. And yes, E is directly proportional to lambda. And second, E is inversely proportional to R. This is the result. This is the result. So here is the whole discussion. That's how you can do it. And this is the whole discussion. That's how you can find out electric field due to infinitely long straight uniformly charged wire or linear charge distribution. Now I am doing it again. I am doing it again on the copy, and you will write down in the same way. Okay, so that you can understand it and you can write it. This is a wire of infinite length. It is going up to plus infinity this side, and it is going up to minus infinity that side. Right? It is having a charge plus q. There is a point P at a distance r. Right? You have to find out electric field on this point. This point P can lie anywhere. This can be here, this can be here, this can be here, this can be here, this can be here. It can be anywhere on the, it will make a cylinder type surface. So our distance can be anywhere. So this is the wire. Now what I consider? I consider a Gaussian surface of length L passing through a distance r from the wire. This is a Gaussian surface. This is a Gaussian surface. Suppose the length of the Gaussian surface, suppose the length of the Gaussian surface is L, and the charge inside the Gaussian surface from this point to this point is Q, right? Now this cylinder is made up of three surfaces. This is surface 1. So I consider a small area element ds1 over here. I consider a small area element ds2 over here, and I consider a third area element over here, that is ds3. This is like this. Now I make electric field. Due to this positive charge, the electric field will be perpendicular and straight away. This is electric field, 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 perpendicular and straight away. This is electric field. Electric field on each point here, here, here. I am calculating electric field here, not here. I am calculating it here. So this is the electric field on each point, which is same. Now this angle is 90 degree, and this angle is 90 degree. This angle is 0 degree. This is the whole picture you have prepared. The point P lies at a distance r from the charge. The linear charge density lambda equals to what? Q by L, or that is equal to dq by d. I write it as a complementary, it is sufficient. If you write like this, it is sufficient. The field and Gaussian surfaces are as according to figure. The field and Gaussian surfaces are as according to figure. Right now, apply Gauss law for whole cylinder. Let me apply Gauss law for whole cylinder. So I may write E dot ds equals q net upon epsilon naught. And this whole surface is made up of three surfaces. This whole surface is made of three surfaces. So let us break it into three parts. E dot ds1 plus E dot ds2 plus E dot ds3 equals q net upon epsilon. So may I write it E ds1 cos 90, you can see the angle between E and ds1, 90, plus E ds2 cos 90 plus E ds3 cos 0 equals how much charge is there inside the surface? By q by epsilon naught. Now this is 0, cos 90 is 0. This is 0, cos 90 is 0. It will come out to be E integration of ds3 equals q upon epsilon naught, and it becomes E into S3 q upon epsilon naught, and S3 is what? S3 is nothing 2 pi r into L. The surface area, this is what S3. S3 is surface area of curved cylinder surface. So this is the case. S3 equals 2 pi r into L. Clear? Now अब आप आगे बढ़ेंगे और इस S3 की वैल्यू पुट करेंगे यहाँ. सो E into 2 pi r L equals Q upon epsilon naught. E equals to 1 upon 2 pi epsilon naught r into Q by L. And what is Q by L? That is equal to lambda, and it will give you the result E equals to lambda upon 2 pi epsilon naught r. This is the final formula. So what is the result? You can write it over here. E is directly proportional to lambda and E is inversely proportional to R. Sorry. So this is the whole result. Now you do it on your copy, and I am reducing its size a little bit. Do it. Do it. Linear charge distribution means this is for line, whole line from plus infinity to minus infinity. This is called as linear charge. Linear means line charge. It is from plus infinity to minus infinity. The charge on this line is plus q. You can consider minus q also, that is your choice. But linear charge distribution is for charge q. This charge is given on the line, that's why we are calling it linear charge distribution. This is the last discussion for today. This is the last discussion, and you will find this lecture till night. In the night, it will be uploaded on your app. On your app. So all of you are requested to download the app so that you can watch the videos of date-wise videos on a particular date. Okay. So you have to download the app first of all. Then you will be able to see the videos. Okay.